Hello students, in this video we will see another shortcut method to find particular integral. So this method is applicable only if f of x, that is right hand side, is of this form sine ax plus b or cos of ax plus b. For sine and cos we have same method. Okay, so I will explain for sine of ax plus b. Similarly, you can use it for cos of x plus b also. So here phi of d operating on y is equal to sine of ax plus b. Then yp will be 1 upon phi of d sine of ax plus b. Now here we just have to replace d square wherever d square is there in phi of d. Replace that by minus times a square. Be very careful, it is not minus a whole square, it is a square into minus 1. For example, if a is 2, we'll replace d square by minus 4, like this. So 1 upon phi of minus a square sine of ax plus d. Here we are replacing d square by minus a square. Alright, provided phi of minus a square is not equal to 0. And if it is equal to 0, so we have case of failure. So this is case of failure. Then yp is equal to, so x times 1 upon phi dash of d operating on sine ax plus b, and we'll continue. Similarly, the same method works for cos of ax plus b also. Everything is same, and here also when phi of minus a square is equal to 0, this is case of failure. We have to take x times 1 upon derivative of phi of d cos of ax plus b. Okay, let us solve one example on this. So here we have to find particular integral of this d square minus 3d plus 2 operates on y is equal to cos of x. So solution, yp is 1 upon, so this is d square minus 3d plus 2 operates on cos x. Now what we'll do here, replace d square by minus of 1 square, that is minus 1, equal to minus 1. So yp is 1 upon, now d square will be replaced by minus 1, minus 3d plus 2 cos x, which is equal to, so it is 1 upon 1 minus 3d cos of x. Okay, now next, as now we don't have d square in denominator, now either you can use general method or you can still use this method, but for that we have to make d square in denominator. So what we can do here, we can multiply divide by 1 plus 3d divided by 1 minus 3d to 1 plus 3d operates on cos x. So which gives us 1 plus 3d divided by, and is 1 minus 9d square cos x. So yp is equal to 1 plus 3d. Now you can replace d square by minus 1, so 1 minus 9 times minus 1 cos x, which is equal to 1 plus 3d, and it is 1 upon, so it is 1 minus 9 times minus 1, so 1 by 10 cos x. Okay, so now we don't have any term of d in denominator, but it is not over it. Now we have to operate this 1 plus 3d on this term, 1 by 10 cos x. So yp, which is 1 plus 3d operates on 1 by 10 cos x. So now it is a derivative 3d, so d represents derivative. So it is 1 operates on 1 by 10 cos x, which is just multiplication by 1, plus 3 times derivative of 1 by 10 cos x, which is 1 by 10 cos x plus 3 times, so derivative of 1 by 10 cos x, which with respect to x will be 1 by 10 minus sin x. So our answer yp is 1 by 10 cos x minus 3 by 10 sin x. So this is how we can find yp when we have function of the form cos of ax plus b. Let us solve next example. Okay, so here we have to find partial integral of d square plus 9 operates on y is equal to sin 3x. Now a is 3. So solution yp is equal to 1 upon d square plus 9 operates on sin 3x. Now you can see here, if you replace d square by minus 1 times 3 square, that is minus 9, we'll get case of failure, right? See here, phi of d is equal to d square plus 9, and therefore phi of minus 3 square, that is phi of minus 9, will be not this. When we replace d square by minus 3, if we replace d square by minus 9, we get phi of minus of 3 square as 0, so which is case of failure. Okay, so what we can do here, so yp will become x times already derivative of d square plus 9 with respect to d, so this into sine 3x. Now next, we don't have d square in denominator, so what we can do, so yp, which is x times 1 upon 2d sine 3x, we can multiply and divide by d, so it becomes d upon 2d square sine 3x, which is x times d. This order is very important. This x is out of this bracket. Okay, we are not operating on x, we are operating on sine 3x only. Now here denominator you can replace by, we can replace d square by minus 9, so this is x upon minus 18 and d of sine 3x, which is x upon minus 18, and derivative of sine 3x with respect to x will be cos 3x into 3. So therefore yp is equal to minus x upon 6 cos of 3x. Now this is how we can solve this particular integral using shortcut method. I hope you have understood this. We will solve one more example on this, so it will get very clear. Now look at this example. You have to find partial integral of this d raised to 4 plus 8d square plus 16 operates on y is equal to cos of 2x. So solution yp is equal to 1 upon d raised to 4 plus 8d square plus 16 operates on cos 2x. Okay, so here A is true. Alright, so first step is what? We replace d square by minus 2 square, which is minus 4. So my p will be 1 upon. So now when you replace d square by minus 4, d raised to 4 will be 16 plus 8 into minus 4 plus 16 operates on cos 2x, but which is 0, right? Look at the denominator. It is 36 minus 16 minus 32 plus 16, that is 0. Okay, so this is case of failure. So yp is, we have to take a derivative of denominator now. So x times, okay, we forgot this, x times. Do not write this x here, okay? Don't write it here. That is not correct way, because we are not operating this on x. X has to be out of the bracket, okay? Alright, what is the derivative of d raised to 4 plus 8d square plus 16 with respect to d? So it is 4d cube plus 16d, and this operates on cos 2x. So yp is equal to, yp is equal to x times 1 upon 4 d cube, which is, what was it, 4 d cube plus 16d, 4 d cube plus 16d operates on cos 2x. Now again replace d square by minus 4. So we get x times 1 upon, now 4 into minus 4 cube, so this is minus 64 plus 64 cos of 2x. Again this is case of failure, as we have 0 in denominator. So again we have to multiply by x, take derivative of denominator, which is 12d square plus 16 cos 2x. So this is x square times 1 upon, now we can replace d square by minus 4 again, so this will be 12 into minus 4 plus 16 operates on cos 2x, which is x square divided by minus 48 plus 16. Okay, so therefore yp is x square upon, this is minus 32 cos of 2x. Okay, so here we had two cases of failures, so therefore we got this x square here. Alright, so this is how we can use these shortcut methods to find particular integral. You can always use general method, but what happens in general method, sometimes this integration becomes very lengthy, so there we can use these shortcut methods. Thank you. I hope you understood this. Solve some examples, try to solve some examples of previous year's question papers, okay, then it will get clear. Thank you.